Hey guys, in this video, we'll talk about threats that Zero Trust architecture is facing. First of all, we have to accept the truth that cybersecurity risk cannot be eliminated. This risk always exists. When complemented with existing cybersecurity policy and guidance, identity and access management, continuous monitoring, and general cyber hygiene, a properly implemented and maintained zero trust architecture can reduce overall risk and protect against common threats. However, the risk always exists, even if we are implementing a zero trust architecture. The first one threat zero trust architecture is facing is subversion of zero trust architecture decision process. It sounds very obscure. We can call it compromise policy administrator. Then you should be able to understand it. In zero trust architecture, an action or request must be approved by policy engine and the policy administrator. They make the final call. But unapproved changes or mistakes that can disrupt enterprise operations can be made if policy engine and policy administrator is compromised. So the position or person in charge of policy engine and policy administrator can be compromised, and this is a very serious potential risk for zero trust architecture. The second one, denial of service attack. DOS attack is a cyber attack that shut down a machine or network by flooding the target with traffic or sending it information that triggers a crash. This risk is not unique to zero trust architecture. It can be used by attacker almost anywhere. In zero trust architecture, policy engine and the policy administrator can be attacked by DDoS attack. Enterprise can mitigate this threat by having the policy enforcement reside in a properly secured cloud environment or be replicated in several locations following guidance on cybersecurity resiliency. Also, machine learning and artificial intelligence could be used to mitigate DOS attack too. Another threat is also common, stolen credential or inside threat. This case is saying that legit accounts could be stolen. Basically, it's targeting on ID management component. Attackers would use every possible approach, including but not limited to phishing, social engineering, or a combination of attacks to obtain credentials of valuable accounts. A contextual trust algorithm is more likely a good way to deal with this threat. The contextual trust algorithm can detect theft patterns that are out of normal behavior and deny the compromised account or insider threat access to sensitive resources. In zero trust architecture, all traffic is inspected and logged on the network and analyzed to identify and react to potential attacks against the enterprise. But some of the traffic on the network still might be not transparent. And this white paper calls this threat visibility on the network. This traffic may originate from non-enterprise owned assets, application or service that are resistant to a passive monitoring, and traffic from attackers might hide among these. But the enterprise can collect metadata to detect attackers. Also, against this threat, machine learning techniques can be used to analyze traffic that cannot be decrypted or examined as well. Another related threat to enterprise monitoring and analysis of network traffic is the analysis component is itself. The white paper doesn't say which component, but it includes at least two components: threat intelligence feed and continuous diagnostics and mitigation system, in short CDM system. Threat intelligence feed, which is used to provide information from internal or external source that help the policy engine make assess decisions. CDM system is gathered information about the enterprise assets current state and applies updates to configuration and software components net traffic. And the metadata are being stored in these components for building contextual policy, forensics, or later analysis. And that data becomes our target for attackers. So apparently these resources should be protected. If an attacker can successfully gain access to this information, they may be able to gain insight into the zero trust architecture and identify assets for further information and attack. Based on this philosophy of identifying threats, another component, ID management, will become a target of attack. Like stored traffic, this component contains a sales policy to resource that can give an attacker information on which accounts are most valuable to compromise. As these components and the resources stored in them are vital to security, they should have the most restrictive access policy and be accessible only from designated or dedicated administrator accounts. The sixth threat, reliance on proprietary data format, a solution. This threat is an extent of last threat. Zero Trust architecture relies on several different data resources to make access decisions. So if one provider has a security issue or disruption because of proprietary data formats or their high dependent, it will be very hard for enterprise to mitigate to a new provider. They might need to replace several assets or to translate policy rules from one proprietary format to another. We can consider this threat as a supply chain risk. Just the supplement is data, not cargo. So enterprise should consider data provider performance, stability, and other properties while choosing them. We mentioned that artificial intelligence can be used in zero trust architecture and gives a lot of help. But this kind of software-based agents that is being deployed to manage security issue on enterprise network could be a threat. We call this threat use of non-person entity in zero trust architecture. The biggest risk of AI is the possibility of false positive and false negatives. False positive is innocuous actions mistaken for attacks. False negatives is attacks mistaken for normal activity. It's possible that an attacker be able to induce or coerce an AI to perform some actions and cause these two kinds of attacks on the system. So when we design and use AI in zero trust architecture, we should not trust it blindly. And that's all 7 threats that zero trust architecture might be facing right now. Thanks for watching. See you in the next one.